Take a look at this piece of paper. Now, if I were to rip it, it's still paper, but it's now in just two smaller pieces. However, if I were to burn it, I'm not going to do that because it would be a fire hazard, but something completely different would happen. It would no longer be paper. We get into all about the difference between a physical and a chemical change right now. Oh, this is dangerous. I'm going to put this down. Okay, let's first start off by talking about the simpler of the two, a physical change. Now, a physical change is when an object does not change its chemical identity. It might break, change size, change appearance, or change phase, but it's still the same chemical composition as it was before. In a physical change, you are not creating anything new. The molecules stay the same. They just might move differently, or the appearance might be a tad different. It's kind of like when you cut your hair. It's not like all of a sudden your hair is no longer hair. It's not tentacles or anything weird like that. It's still hair. It just might look different and might look amazing. Somebody's fabulous! Physical changes can happen in a lot of different ways. However, it's usually when an object changes its size, shape, or state of matter. Let's first talk about phase changes. Everyone's favorite example, water. Now, water's chemical composition is H2O, but water can change phases. It can go from a solid to a liquid by melting. It can go from a liquid to a solid by freezing, and it could go from a liquid to a gas by evaporating. It can also change phases in a couple different ways. But no matter what phase water is in, if it's a gas, a liquid, or a solid, it's still water, and it still has the chemical composition H2O. So those are physical changes. Some types of physical changes are called mechanical changes, which means they change their size or appearance. This could be like shredding paper, chopping wood, or really grinding stone. There are a ton of different examples of these types of changes. Another sneaky physical change is dissolving. Let's say you were to put a bunch of salt into water. When you drink that water, it will obviously taste, well, salty. It's not like Kool-Aid. It won't be delicious. But this is the same principle. The salt is actually still in the water. You just can't see it, but it's hiding between the water molecules. It's still salt. It still has the same chemical composition. It just looks a little bit different. So that is actually a physical change as well. One key difference between a physical and a chemical change is that a physical change can be reversible, whereas a chemical change cannot. Okay, so that's a physical change. Let's move on to something way more complicated, a chemical change. A chemical change happens at the atomic level with the atoms, all right? Bonds are broken and new ones are created. Something entirely new comes out of whatever was put in. You go in with something and you come out with something completely different. Some examples of chemical changes could be combustion or the burning of wood or other items. What used to be wood is now ash and smoke and energy. Another example is oxidation, which is when metals are exposed to certain conditions and begin to rust. Or what about one example from the human body, metabolism, when your body breaks down food and turns it into energy for you to use. Cooking can also be an example of a chemical change like frying an egg or baking bread. Unlike physical changes, chemical changes are not reversible. You can't really unfry an egg or, put a log back together after it's been burned. It's gone, I'm sorry. I'm gonna miss that log. He was so nice. I actually didn't know them that well, so this is all acting. When a chemical change occurs, we call it a chemical reaction. And there are some important vocabulary terms you should know when we talk about chemical reactions. To help explain these vocabulary words, I'm going to pretend like we're doing a simple chemical reaction at home, using baking soda and vinegar. The first vocabulary word is reactants. That is the ingredients that go into the chemical reaction. In this case, our ingredients are baking soda and vinegar. Remember I said when a chemical reaction occurs, something new is created. And that new substance, whatever it is that is created, is called the product. In this case, when we mix baking soda, vinegar, carbon dioxide is created, or a gas. You can see when the reactants are mixed, the bag begins to inflate. That gas was not there before and is a product or creation of this chemical reaction between the reactants. Now, the product of a chemical reaction is not a gas, it might be a precipitate, which is a solid created by a chemical reaction. So here are a couple different ways to tell if what you are mixing is making a chemical reaction. First, we talked about gas. You could see if an object inflates, but you could also see if you see bubbles or smell something a little bit different. You can also look for an unexpected color change. That could be a sign of a chemical reaction. If you see a new solid forming, that is a precipitate and a clear sign of a chemical reaction. Lastly, you can see if the object has changed its temperature, whether it's gotten colder or warmer. That could also be a sign of a chemical reaction. All right, everybody, that's all the time we have for today. Remember, physical changes are a lot more simple than chemical ones. Physical changes don't produce anything new, and they usually just deal with a change in size, shape, or phase. Chemical changes change the entire chemical composition of a substance and require a chemical reaction to occur. You go in with something, and you come out with something completely different. All right, everybody, thanks for watching.